Hello class, in this video we review for the final exam. The final exam has 30 questions. This review has 52 questions. Let's get started. Final exam covers all the 4 chapters. Question number 1. Decide whether the limit exists. If it does, find the value. So we'll consider the limit of the function f when x approaches -1. Let's look at the graph. At -1, this is the x-axis, this is the y-axis, so this is the origin. When x equals -1, the function has a jump, right? When variable x approaches to 2 from the left, variable y approaches to -2, right? Again, the limit of a function is the value that the variable y approach when x approaches 2. When x approaches 2, my bad, I'm sorry. When x approaches -1 from the left, y approaches -2. This is the origin, so this is -2. When x approaches -1 from the right, y approaches to -7, so -2, -7. Left-hand limit and right-hand limit. Second question. In a particular city, taxi cabs charge passengers $3.70. Okay, I think you can take time to read this question, but mainly we need to understand the graph of the function. The function here is the cost, the taxi fare, and the function, is c of x. The function is a piecewise function. So we have a piecewise function that is given, and we need to consider the left-hand limit of the function when x approaches 0.2. Let's see, where is the 0.2? 0.2 is right here. When x approaches 0.2 from the left, y value approaches 4.2. That's the left-hand limit, 4.2. Second part is to find the right-hand limit when x approaches 0.2 from the right. You can see this piece. We're going to look at this piece. When x approaches 0.2 from the right, y variable approaches 4.7. Part C. Part C is to determine if the function has a limit when x approaches 0.2. Although both two one-sided limits exist, the two one-sided limits are not equal to each other, so the limit does not exist. Left-hand limit is 4.2, right-hand limit is 4.7. They are not equal. Question number 3. We need to find the limit of the rational function here. If we plug in x equals 94, we'll see the numerator is 0, the denominator is also 0. So we have to rewrite the function The rational function numerator is x squared minus 16, and that is x plus 4 times x minus 4. Denominator x plus 4. Numerator and denominator have common binomial factor x plus 4, so they can cancel. And we have the function x minus 4. When x approaches -4, x minus 4 approaches to -4 minus 4, which is -8. Question number 4. We need to consider left-hand limit, right-hand limit, and the limit, and the value of the function at the 4, and determine if the function continuous. Part A, select the correct choice below. The function is given, whose graph is given. Obviously, at this is the origin, right? 1, 2, 3, 4. At 4, the two one-sided limits are not equal, and we should see the function do not have a limit when x approaches 4. The function is not continuous either at 4. But the two one-sided limits do exist. The left-hand limit, when x approaches 4 from the right, variable y approaches 1, 2, 3, 4, 5, 6, approaches 6. So the right-hand limit is 6. Left-hand limit, when x approaches 4, left-hand limit is 1, 2, 3. 0, 1, 2, 3. Positive 3. As I mentioned, left-hand limit and right-hand limit are not equal, so the limit does not exist. The value of the function at 4 is 3, because we see the solid dot here, right? When x equals 4, the corresponding y value is 3. Part D, is the function continuous at 4? Obviously not. It's because the limit does not exist. In order for a function to be continuous at a certain point, the function must have the limit at that point. Also, the limit has to be the same with the value of the function at that point. Since the limit does not even exist, the function is not continuous. So we should choose no. Not continuous at 4 because the limit does not exist. Question number 5. We are given a piecewise function. We need to determine if the function continuous at 4 or not. Some of the questions we have already seen in the midterm review, right? Very similar. We'll consider the continuity of the function at 4 only when the left-hand limit of the f, when x approaches 4, left-hand limit, right-hand limit, and f of 4. Only when all the three things exist and equal, the function is continuous at 4. So let's see. When x approaches 4 from the left, that means x is less than 4. X is less than 4, then we should use the function 1 over 4x plus 7, the first piece. When x approaches 4, 1/4 of 4 is 1. 1 plus 7 is 8. The function approaches 8. The right-hand limit, when x approaches 4 from the right of 4, that means x is bigger than 4. So we have to use the second piece, 5x plus minus 9. When x approaches 4, 5 times x approaches 5 times 4, which is 20. 20 minus 9 is 11. So we don't really have to continue. We know this function is not continuous at 4 because the two one-sided limits are not equal to each other. Okay, so we don't have to continue. We can make a decision. The function is not continuous. The function is not continuous because the limit does not exist. This one, first part is similar with the previous problem. The second part is about differentiability. Let's answer the first part first. Determine the function if the function continuous at 2. I mentioned earlier, in order for the function f continuous at 2, those three things. Left-hand limit at 2, right-hand limit at 2, and the value of the function at 2 all have to exist and equal to each other. So this one, left-hand limit when x approaches 2 from the left. Since x is less than 2, we use the first piece, x squared plus 3. When x approaches 2, x squared approaches 4. 4 plus 3 is 7. When x approaches 2 from the right, that means x is bigger than 2. Since x is bigger than 2, the function equals 2x plus 3, the second piece. When x approaches 2, 2x approaches 4. 4 plus 3 is 7. And this, so far, since we found the left-hand limit and right-hand limit and they are equal, the function has a limit. The limit of the function exists at 2. And we have to figure out what's the value of the function at 2. You see the first piece has x less than or equal to 2. So when x equals 2, we use the first piece. We're gonna plugging in x equals 2 in x squared plus 3 right here. When x equals 2, x squared is 4 plus 3 is 7. Okay, all the three things exist and they are all equal to 7. So based on that, the function is continuous at 2. This is continuous. Okay. Yes, continuous. Second part is to determine if the function differentiable at x equals 2. An easier way to process that part is to use the graph. Since the two pieces are not very difficult format, as you can see, we have 1, 2, 2 here, right? When x is less than or equal to 2, the function is a parabola. X squared plus 3 is a parabola, right? Opens upward. 1, 2, 3 is a parabola. When x is bigger than 2, the function is a straight line with a slope 2. Y-intercept is 3. 1, 2, 3. So it looks like slope is 2, so passing through this one, passing through the like this, right? It's a straight line. It's not a very good graph. It should be look like parabola and then a straight line. So since at this point the slope does not exist, the function is not differentiable. So the function, if we have the graph of the function and the function is not smooth, the curve of the function is not smooth at a certain point, then the function is not differentiable at the point. Based on the graph, we know the function is not differentiable at 2. Question number 7 is to find the derivative. I mentioned it's helpful to know the derivative of 1 over x is -1 over x squared. And this problem, we can use this formula for the second part of the function. The first part is 6th root of x. In the exponential form, it is x to the power 1 over 6. So the derivative of the first part of the function is 1 over 6, bring 1 over 6 in front of x, and then raise x to the power 1 over 6 minus 1. Okay? And then minus 8 times the derivative of 1 over x, which is a negative 1 over x squared. All right? So we keep the negative sign here, keep the 8 here. Take the derivative of 1 over x, which is a negative 1 over x squared. Next step, we are going to simplify. 1 over 6 minus 1 is 1 over 6 minus 6 over 6, which is negative 5 over 6. And negative times negative is positive. So we have a positive 8 over x squared. Let's see if the problem a multiple choice question. Oh, it's not. Since the original function is a radical function, and then I would rewrite the result. I would write the result also in the radical form. Firstly, we need to get rid of the negative sign, right? So we have 1 over 6, x 5 over 6. I believe this is good enough. X to the power 5 over 6 is the 6th root of x to the power 5. Let's firstly enter this to see if the system marked it correct. And numerator is 1 and plus 8 over x squared. We're going to enter that in the cell. Numerator is 1, denominator 6, x to the power of 5 over 6. 5 over 6. And that's the first part. Double check. And plus 8 over x squared. It works. So that means we do not have to write x to the power of 5 over 6 as the 6th root of x to the power of 5. And this is good enough. Question number 8. In 10 years, the population of a certain city grows from 700,000 to a size p given by this function. We have 4 parts to complete. The first part is to find the derivative. find the growth rate. This function is pretty simple. Two parts in the function. The first part is a constant. When we take the derivative of the constant is 0. And look at the second part. The second part is a simple power function. The derivative of t squared is 2t. So the derivative function of the population function is 4,000t. 4,000t. Part B, we need to find the population after 20 years. P of t here is the population. T is the time in years. After 20 years, then we just need to plug in t equals 20, right, into the function. So for part B, we plug t equals 20 into this function, population function. Simplify your answer. Let's see. I'm going to use the calculator here. A good thing about the TID4 calculator is we can enter the expression in the calculator. 700,000 plus 2,000 t squared. 2,000 t squared. Okay, what is t? It says 20 years, right? So t is 20. Plugging in 20 to the power, I think, to the power of 2. To the power of 2. We got 1,500,000. 1.5 million. 1.5 million. 1, 2, 3, 1, 2, 3. 1, 2, 1, 2, 3, 1, 2, 3. We should have 5 zeros here. Yep. Part C, the growth rate at t equals 20. T is 20, but this time we're going to plug t equals 20 into this derivative function, the derivative of the population, because we need to know the growth rate, right? So we're going to plug 20 here. And 4,000 times 20, that is 80,000. And how do we interpret the result from part C? The growth rate tells the average growth after time t and t equals 0 and t equals 20. B, the growth rate tells the rate at which the population is growing at time t equals 20. Growth rate tells the rate at which the population is growing at time. This one definitely is wrong. Not 19 years. It has to be t equals 20. Growth rate tells the difference. It's not that one. It's going to be B. Question number 9. Take the derivative. Okay. This function is a quotient function. So I'm going to use the quotient rule to take the derivative of the function. We would let f be the numerator and g be the denominator. So f is 5x squared. G is 7 minus 4x to the power of 4th. F prime, this derivative of x squared is 2x. So f prime is 5 times 2x, 10x. G prime, take the derivative of g. We use the chain rule. You should remember chain rule, right? The outside function is u to the power of 4th. So 4u third. and then multiply the derivative of the inside function. The derivative of the inside function is 94, is a linear binomial. 94 is the slope, right? And then we simplify. 4 times 94 is negative 16. Negative 16 times 7 minus 4x to the power of 3. That is a g prime. To find a g prime, we use the chain rule. All right? So now we're going to remember what's the quotient rule. The derivative of f over g is f prime g minus f g prime all over g squared. G is right here. Raise the function to the second power. It's already a fourth power here, right? If we raise to the power 2, then 4 times 2 is 8. So the denominator is 7 minus 4x to the power of 8. That's the denominator. Numerator, f prime. F prime is 10x times g. G is 5x, G is 7 minus 4x to the power of 4th. F prime g minus f g prime. F g prime, which is negative 16, times 7 minus 4x to the power of 3. And then we are going to simplify the numerator. 10x, 7 minus 4x to the power of 4. And here minus positive. What's 16 times 5? 80? Yeah. 80x squared times 7 minus 4x to the power of 3. Denominator 7 minus 4x to the power of 8. You remember I mentioned this left ear, right ear, head, right? It's a Mickey Mouse. Only when the left ear, right ear, and the head of the Mickey Mouse all have the common factor, we can cancel the common factor. In this case, the common factor is 7 minus 4x to the power of 3. Okay? The left ear has a factor, the cube of 7 minus 4x. Right ear also, the head is also. So we're going to get rid of that common factor. We would have the left ear. Since we cancel a cube, we're going to have 1 only. And then the right ear cancel the whole thing, right? 80x squared. The denominator, it was 8th power. Now we get rid of 3. 3 of the 8, we're going to have 5. 7 minus 4x to the power of 5. And we can keep simplifying the numerator. We can do that right here. 10x times 7, 70x. 10x times 7, 70x. And the minus 40x squared, right? Distribute. 70x minus 40x squared. And then plus 80x squared. 70x, negative 40 plus 80 is positive 40x squared. So the numerator is 70x plus 40x squared. The denominator is 7 minus 4x to the power of 5. This is the final answer. Let's see if the question, it's not a multiple choice question, where we would have to enter the result. Numerator 70x plus 40x squared. 70x plus 40x squared. 70x. Denominator 7 minus 4x to the power of 5. Parentheses. 7 minus 4x and raised to the power of 5. We double check the denominator. 7 minus 4x to the power of 5. Okay. Question number 10. Is a double prime? Yeah. We're going to find the second derivative of this function. This is a composite function, so we would have to use the chain rule. We can let the outside function be u, y equals u to the power of 9. The inside function is u equals x squared plus 2. dy dx is dy du times du dx, right? So let's see what is dy du. Power function 9, u 8. Du dx 2x. So the first derivative, dy dx, which is f prime, equals dy du times du dx, gives 9 times u to the power 8th times 2x. And what is u? U is this binomial. 9 times u is x squared plus 2 to the power of 8 u squared. U to the power of 8th, x squared plus 2 times 2x. And that gives 9 times 2 is 18, x squared plus 2 to the power of 8th. So that's the first derivative. And now we're going to look at the second derivative. I'm going to use f for the first function in the product. So this is the product, okay? So I know the f is the original function. So here we are going to give f a different meaning, just for convenience. The first function f is 18x. The second function in the product is x squared plus 2 to the power of 8th. So dy dx is f times g, okay? It is f times g, And we are looking for the derivative of f times g by the power rule, product rule. We have f prime g plus f g prime. F prime, 18, g prime, similar with what we done earlier, right? Use the chain rule. Bring a in front, x squared plus 2 to the power of a minus 1 is 7, and then times the derivative of the inside function, which is 2x. Simplify. We have 2 times a is 16x, x squared plus 2 to the power of 7. So the second derivative, d2y over dx squared. So sometimes I say that, but doesn't mean is correct. Actually, it's not the right way to say it. This thing is one whole thing. That is one symbol. That's the operator, second derivative operator. D squared y dx squared. That is the second derivative of the function equals f prime g plus f g prime. F prime is 18 times g x squared plus 2 to the power of 8th plus f g prime. F is 18x, g prime 16x, x squared plus 2 to the power of 7. 18 x squared plus 2 to the power of 8. 18 times 16 times x squared plus 2 to the power of 7. And the two parts in this expression has a common factor, 18 x squared plus 2 to the power of 7. So we're going to factor that out. In the first part, we have x squared plus 2. Second part, we have 16 x squared. Let me double check. 18 is factored out, and 7th power is factored out, so 16x squared is the leftover. From the first part, we have x squared plus 2. Okay. And simplify the stuff in the bracket. We have 17x squared plus 2. So this is the final answer for the second derivative. We would have to enter it. 18 x squared plus 2 to the power of 7. X squared plus 2 to the power of 7. Times 17x squared plus 2 times 17x squared plus 2. Question number 11. For the function y, find the d4y dx4. So the fourth derivative. Luckily, the function is not that difficult, so we would have to take the derivative 4 times. Understand the symbol. Okay, so y equals 9x to the power 5th. Okay, first derivative, keep the constant coefficient. The derivative of x to the power 5 is 5 times x to the power 4th. And that gives 5 times 9, 45, x to the power 4th. That's the first derivative. And now we do the second derivative. The second derivative is the derivative of the function we just got, right? The first derivative. And keep the coefficient. The derivative of x to the power 4th is 4x to the power 3. 45 times 4 is 180, x cubed. And third derivative, just keep going. Keep 180. The derivative of x cubed is 3x squared. 18 times 3, 54. 540 x squared. So that's the third derivative. The fourth derivative, keep going, 540 as the coefficient, keep it. The derivative of x squared is 2x. Twice of 540. This is the final answer. Question number 12. Find an equation for the line tangent to the graph of the given function at the indicated point. We had a similar problem in the midterm review, right? I believe you have practiced a lot when you do homework. Function f is 32 over x. The derivative of the function, remember the formula I made you to memorize? The derivative of 1 over x is negative 1 over x squared. It's very useful because a lot of time the frequency that you have to apply this formula is so high and it's really worth it. You just memorize it. So the derivative is going to be negative 32 over x squared. Okay, 32 remains as the coefficient, stay in the numerator. The derivative of 1 over x is negative 1 over x squared. And now we're going to plug in x equals 1. This is an ordered pair representing a point on a curve, also a point on a tangent line. So the first component is x, second component is y. So x equals 1, so plug in x equals 1. Then we have negative 32 over 1 squared, which is negative 32. All right, so that means what? That means the slope of the tangent line. Let's say the tangent line is y equals kx plus b. We should be very familiar with this formula, right? That's the slope-intercept form of a straight line. Now we have f prime of 1 is negative 32. That means the slope of the line we're looking for is negative 32. If we can find the value of b, then we are done. The equation is found. How do we find the value of b? This point is on the line, so we are going to plug in x equals 1, y equals 32. Y equals 32, x equals 1, positive 32, negative 32. B has to be 64. B has to be 64 positive in order for this equation to be true statement. So B is 64. With that found, the equation of the line, the tangent line, is y equals negative 32x plus 64. Y equals negative 32x. Or is a multiple choice question. So negative 32x plus 64, part A. Answer choice A. Question number 13. Evaluate the derivative at a given value of x. Is that the first derivative? Okay. Knowing if you go to the testing center, you need to use the lockdown browser. That means you are not able to zoom in, zoom out. It's gonna be small. So if you need to bring your glasses, you should do so, okay? We are going to solve this problem. Take the derivative first. Keep 94. X squared 2x. The root of 7x is 7. The root of 95 is 0. 75, negative 8x plus 7. And now we're plugging in x equals 5. Negative 8 times 5 plus 7. Negative 40 plus 7. Negative 33. B. Question number 14. Differentiate. Okay, so let's see. Let's take the derivative of this rational function. This is a multiple choice question, right? And later we can compare. Let's see if we can simplify the function itself. Not really. So we are going to use the quotient rule. F over G. F numerator, 2x minus 7. G denominator, 7x squared plus 2. F prime, 2. G prime, 14x. The derivative of the constant is 0. Okay, then f over g to the f over g's derivative is g squared on the bottom. In the numerator, f prime g minus f g prime. G squared, so we have 7x squared plus 2 to the power of 2. Numerator, f prime 2 times g, 7x squared plus 2, minus f, 2x minus 7, times g prime, which is 14x. Let's simplify the numerator. Distribute. Double G term in the parentheses. 14x squared plus 4. And here also distribute. Negative 28x. Distribute this, and here. Be careful with the sign. Negative 28x squared. This is going to be positive 98x. 14 times 7. That is 98. Let me double check. So this part, if you don't feel comfortable with the 14x to the right, you can rewrite it. You can write negative 14x times 2x minus 7, right? It actually for me, it feels better. So negative 28x squared, and then negative is positive 98 times x. Okay, it's correct. denominator, numerator. We can combine those two terms. Be careful, that's negative. So negative 14 x squared and 98x plus 4. Denominator 7x squared plus 2 to the power 2. So this is a multiple choice question. Let's see. Do we have an answer choice? Give the same answer. Negative 14x squared. 98x plus 4. This one. B. Question number 15. Find the derivative of this function. If it's a multiple choice question, we should always take a glance, quickly check the 4 answer choices. As you can see, the answer choices is in the exponential form. So even has a negative, we keep the negative. We don't have to bring it in the denominator. So get an idea about the result, the format of the result. Okay, so the function is in a radical form. We are going to rewrite that as exponential form. X to the power 8 plus 8x to the power of 1 over 5. Okay, 1 over 5. The index 5 is in the denominator of the exponent. And we can try chain rule, right? If you like, y is u to the power 1 over 5, outside function, u equals x to the power a plus 8x inside function, dy du 1 over 5, u to the power of 1 over 5 minus 1, 1 over 5, u to the power of negative 4 over 5, 1 over 5 minus 5 over 5. 95 plus 1, 94. Yeah, exactly. And du dx is 8x to the power of 7 plus 8. Simple power function. And dy dx, by the chain rule, we are going to multiply them together. 1 over 5, u to the power of 94 over 5, times parentheses ax to the power of 7 plus 8. And u is x8 plus ax to the power of negative 4 over 5, and then 8 x to the power of 7 plus 8. We can factor 8 out here, right? But let's see. Do we need to do that? We don't, because the answer choice doesn't do that. This one is wrong on the exponent. This one seems the same with mine. Double check. Okay. Question number 16. If s is a distance function given by this equation, find the acceleration function. Do we have a similar problem in a midterm review yesterday? Similar thing, okay? Acceleration function is the second derivative of the distance function. Distance function s of t, 6t to the power of 3 plus t plus 4. The velocity function is the first derivative of s. So 18, I can actually slow down. So keep the coefficient. T cubed, the derivative is 3t squared. And the derivative of t is 1. The derivative of 4 is 0. Simplify. We have 3 times 8 is 3 times 6 is 18. T squared plus 1. That's the velocity function. Acceleration function is the derivative of the velocity function. And we going to take the derivative of this function, right? Keep 18, the coefficient, the derivative of t squared is 2t, the derivative of 1 is 0, and that gives 36t. That's the acceleration function, 36t. B. Question number 17. This is too small for me. I'm gonna, yeah, this is better. Differentiate the following function. The function is a product. We're gonna use the product rule to take the derivative. And on my guided note, I do the same thing, right? I scratch this out, cross this out, and I change it to y. Because I'm going to use f to represent the first part in a product. This is the first function, this is the second function. The two functions multiplied together is the original function, right? So because I want to use f as x to the power 9, g is e to the power 5x. So I changed the original notation. Okay, so what is f prime? F prime is 9x to the power 8th. What is g prime? G prime is 5e to the power 5x. Okay, we got this by using chain rule. Outside function, derivative is e to the power 5x times the derivative of inside function. Inside function is 5x, so the derivative is just 5. Okay. You actually can try this formula if you look at the guided note carefully. I recommend you know this. The derivative of e to the power kx is k times e to the power kx. All right. Power rule, sorry, product rule. Product rule, f times g prime is f prime g plus f g prime. F prime g, you multiply those two together. F prime is 9x to the power 8th times g e to the power 5x plus f times g prime 5e 5x. 9x to the power 8 e 5x plus 5x to the power 9 e to the power 5x. Is this a multiple choice question? No? Okay. So I'm gonna factor out. I see we have x to the power 8th here, 9th here, so GCF is x to the power 8th, and also e to the power 5x. So factor that out. The first part has left over 9. Oops. And the second part has left over 5x. Yeah, this is going to be the answer. X to the power 8 e to the power 5x and times parentheses 9 plus 5x. Double check. X to the power 8 e to the power 5x, 9 plus 5x. Question number 18. By the way, when you do your homework quizzes, review, the system give you immediate feedback, and you have more than one attempt. But when you take the 2 exams, midterm and final, you don't have that luxury. You only have one attempt. You won't have the immediate feedback. Be aware of that. Question number 18. We have this function, right? That's the graph of the function. It represents a company's total cost. This is a cost function. In millions of dollars is given by C of t. It's exponential function, where t is the time in years. Since the startup date The graph of C of t is shown to the right. Find each of the following. A. The marginal cost C prime. Okay. Then we copy paste the cost function, and then we take the derivative of the function to get the marginal cost function. C prime of t constant, so the derivative is 0, right? Keep the coefficient -70, and the derivative of e to the power of negative t is -1 e to the power of negative t. -1 here is the k. Earlier I gave you the formula. So here we don't have x, but we have t as the independent variable, and the k is -1. -1 e to the power of negative t. Okay, so is negative times negative is a positive, positive 70 e to the power of negative t. So that's the answer. The marginal cost 70 e to the power of negative t. 70 e to the power of a negative t. Part B is to find the C prime of 0. So just plug in 0 here, right? When t is 0, e to the power of 0 is 1, so 70. C prime of C, then plug in 6. We would need to we would need to use the calculator for this one. The function is 70 e to the power of negative t, and we're going to plug in t equals 6. 70 e to the power of negative t. This is a negative. I mentioned this before. This is a minus. Do not use minus. Instead, use this negative sign. Negative t, and t is 6. Okay. And the dollar is in what? In millions of dollars. So here it doesn't say in millions. Instead, we need to find out the dollar. So this is something we need to pay attention. And also, how do we round it? Simplify your answer. Round it to the nearest 1,000 as needed. Do not include the dollar symbol in your answer. That also need to be aware. Something you need to pay attention to. So what do we have in a calculator? 70 e to the power of -6 is in millions. So I'm gonna have to multiply a million. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that's what the cost, marginal cost in dollars. And we need to keep that value to the nearest 1,000. So keep 3 decimal places. 1, 2, 3. 4 is less than 5, so go to down, round it down. 1, 7, 3, 5, 12. 1, 7, 3, 5, 12. Point 652. 652. It says round to nearest 1,000. So the dollars, so the marginal cost per year at year 6 is $173,512.65. 65 cents, and I think Of course, rounded to the nearest tens make more sense, but it requires us to round to the nearest thousandth. Oh, hold on. Nearest, oh, my bad. Almost make mistake. Rounded to the nearest thousand, not th. That means this is ones, this is hundreds, this is thousands. That means we're gonna do ones, tens, hundreds. This is thousands. That means we're gonna do 4,000 here. 4,000. Okay, this question, this part C, you need to pay very attention. Okay, just now I almost made a mistake. It's not rounded to the nearest thousandth th. If it's th, after this word, you keep 3 decimal places. But here is to round to the nearest thousand. That means this is a ones, this is a tens, this is a hundreds, this is a thousands. You need to keep the nearest thousands. Be very, very careful. And also earlier, after I plugging in at t equals 6, this value is in million dollars. You have to multiply by a million to get the dollar amount and then round it. Yeah, this part I'm not sure how many of you can get it right. It's a little bit challenging. We need to be very, very careful. And part D is to find the limit of C of t, not a C prime. Okay? C of t is right here. On my note, we let t approaches infinity. 120 minus 70 e to the power of negative t. 120 is not affected by t. So minus, we can write the second part in the function as 70 over e to the power of t. Okay, so when t approaches infinity, this part approaches infinity. Okay, numerator is a constant, denominator approaches to infinity, so this quotient approaches to 0. 120 minus 0 is 120. So the limit is 120. As you can see, y equals 120 is asymptote, right? Is asymptote. That means when you over time, the cost will not go up anymore. In the beginning, the cost, to get everything ready. So when you over time, in the beginning, the cost is going up. By a certain point, you're gonna approach to a certain value, which is 120 million. This one we do not have to multiply a million because it already have a million here. Simplify your answer. Do not include the dollar sign in your answer. That could be this could be a challenging problem. Did I finish this one? No. Oh, okay. So we also need to find the derivative. Sorry, we also need to find the limit of the marginal cost function. And I have the marginal function here. So this time we're going to find the limit of 70 e to the power negative t. That t approaches infinity. And that is the limit t approaches infinity. I can rewrite the function as 70 over e to the power t. So when t approaches infinity, the denominator approaches to infinity. So the quotient approaches 0. So the limit is 0. Marginal cost 0. It doesn't go up anymore at a certain point. Question number 19. The demand for a new computer game can be modeled by this function. Look at the function. It involves two variables, P and X. P is the price. Okay, we need to remember P is the price. Consumers will pay in dollars, and X is the number of games sold. So X here is the number of games sold. In thousands, this is also, it might be important, but in thousands, recall that total revenue is given by R of X equals X times P of X. Well, this helps. Complete part A through part C. Find the revenue function, okay? We have the demand, we have the function, the demand function given. We need to find the revenue function. Revenue function R of X. R of X is P of X price times the number of items you sold, right? You sold this many items, and each item, for each item you charge this much dollars, and you multiply them together. That's how much revenue you have. So it is P of X is 51 minus 7 ln X, 51 minus 7 ln X times X. Distribute 51x minus 7x ln X. I would enter this as a revenue function. $51 minus 7x ln X. Technically, we should also put a domain. It doesn't mention that. I'll give it a try, okay? I'm not sure if you require to get that or not. So let's try. Okay, that means we don't have to. But knowing X is bigger than or equal to 0, less than or equal to 800 as well. Part B is to find the marginal revenue. Take the derivative. The derivative of 51x is 51. The derivative of this function, okay, we can do that here, okay? X ln X. Take the derivative of X times ln X unchanged, plus keep X unchanged and times the derivative of ln X. The derivative of X is 1 times ln X plus X times the derivative of ln X is 1 over X. So ln X plus 1, or 1 plus ln X. So we got that part, right? This part, we got the root of this part. And we keep the coefficient -7 and bring this here, 1 plus ln X. Let me double check. The root of 51x, 51 minus 7. Yeah, that's correct. That's correct. Simplify 51 minus 7 minus 7 ln X. 51 minus 7, 44. Minus 7 ln X. 44 minus 7 ln X. Part C. How many units will be sold if the price that consumers are willing to pay is $50? Price is $50. The number of units that will be sold is, round to the nearest whole number is needed. Let's see. How many units will be sold? X here is the number of units sold. And if the price, yeah, we're gonna just use the demand function, okay? We're going to plug in P, price is 50, and then solve for X. The demand function is right here. P of X, P equals 51 minus 7 ln x. We are looking for the value of x. What we know is the value of p. Is that $50? P is $50. Okay, so let P be $50, and it's 51 minus 7 ln x. We solve for x. Minus 51. We have -1 equals -7 ln x. Multiply -1 to each side, so positive, positive. Then we have 1 equals 7 ln x, or 7 ln x equals 1, divided by 7, ln x equals 1 over 7. Sorry, I don't have enough space here. And we can convert that to the exponential form. X is going to be e to the power of 1 over 7. Okay, x is going to be e to the power of 1 over 7. Let's use the calculator. Oh, sorry. Let's do it again. Second, okay, e to the power of, what is it? 1 over 7. Is really this little? X here, oh no, X is in 1,000. Yeah, it doesn't matter. It doesn't matter. So X here is the number of games sold in thousands. So that's why this number is so small, times 1,000. And then round it to the nearest whole number, 1154. Because 5 is bigger than or equal to 5, so round it up. 1154, 1154. Okay. Question number 20. For the scatter plot on the right, determine which, if any, of these functions might be used as a model for the data. We have the following 6 different types of functions: quadratic, exponential. This one is exponential growth. This exponential decay. Polynomial but not quadratic. This one logarithmic growth. This one is a logistic. Okay. This one looks like exponential decay. Number of fruit flies by day. Okay, so definitely is number of fruit flies. Why is it getting down? So definitely is exponential function. Since it's going down, is exponential decay is going to be this one. Okay, exponential decay is this one, F. Same requirement, but the function, the graph is different. And this one, look like polynomial of degree 3. But I need to double check. Let's see the y-axis. It says population in thousands. Population in thousands. Not quadratic for sure. Not exponential growth or decay. It does not look like a log function. To me, it looks like polynomial function with degree 3. I'll give it a try. Oops. I think it's a logistic. So it's good to actually study this six type of functions, right? I think the reason the answer is this function is because it has a horizontal asymptote. But to be honest, it doesn't really show that very clearly. But since it's a population, you don't want to, if we choose a degree 3 polynomial function, is go up forever. So means population go up forever. But we know population at a certain point, it won't go up forever, right? It has a horizontal asymptote. So yeah, this is the logistic function. Supposed to be this answer choice. I would like you spend time to study these six type of functions and their graphs. Next, question number 22. Differentiate, okay? Let's see. We're looking for dy dx, okay? Okay, so it's exponential function. When we take the derivative, this part definitely becomes 0, right? So that's not an issue. The challenging is this function. So let's review what is the derivative of a to the power of x. I think is a to the power of x times ln a. Yeah, that's the derivative for exponential function with the base not equal to e. All right, so I would try chain rule here. I would let y equals 7 to the power of u, and then u equals x to the power of 3. Again, the 5 here is not an issue because the derivative is going to be 0. And dy du, use the formula. We have 7 to the power of u times ln 7. Du dx is 3x squared. So dy dx is dy du times du dx. Dy du 7 to the power of u times ln 7 times du dx, 3x squared. U is x cubed times ln 7 times 3x squared. Simplify the result. We can write 3 ln 7 in front as constant, and then 7 to the power of x cubed, and then times x squared. Okay. Is it a multiple choice question? No, we would have to. Oh, hold on. I made a mistake here. I thought that the 5 is in the exponent. My bad. So that means the u is plus 5. So 7 to the power of u is x cubed plus 5. It doesn't really change nothing though. Oh, change this here, plus 5. Change u here, plus 5. And other things does not actually affect it. 3 ln 7. Let me put a parenthesis, frame that. Seven to the power of x squared plus 5. No, x cubed plus 5. Let's see. 7 x cubed plus 5. and then times x squared. X squared. Okay. Next, question number 23. Differentiate. This is a log function. Do you remember the formula for log function? With base not equal to e. If its base is e, we know the formula, right? So what is the formula? Let me think. LG with base ax, the derivative is x ln a. I think this is the formula. So the derivative of this function is going to be 1 over x ln 3. 1 over x ln 3. Question number 24. Differentiate exponential function. Let's do that. We can use the chain rule. We can let y equals e to the power u, u equals 9 minus 3x, dy du is e to the power u, du dx is negative 3. dy dx is dy du, du dx, dy du e to the power u, du dx, negative 3. Negative 3 e to the power u, which is 9 minus 3x. So negative 3 e to the power 9 minus 3x. This one, B. Question number 25. Find the derivative of the function. Okay. Natural logarithm function. We're going to use the chain rule again. Outside function, y equals ln u. Inside function, u equals 3x squared, 3x cubed. 3x cubed minus x squared. dy du, 1 over u. du dx, 3 times 3 is 9, x squared minus 2x. dy dx is dy du times du dx. 1 over u times 9x squared minus 2x. 9x squared minus 2x. U here is 3x cubed minus x squared. X here has to be non-zero, so that make it's possible to develop cancel a common variable, common factor x. So the numerator is 9x minus 2. So we have 4 terms in a quotient, right? Rational function. Get rid of a factor x from each of the 4 monomials terms. 9x minus 2, here is 3x squared minus x. 9x minus 2, it's multiple choice question, so it's good. 9x minus 2, 3x squared minus x. This one, the last one. Question 26. Draw a graph to match the description given. F of x has a negative derivative over negative infinity to negative 1 and 2 to infinity, and a positive derivative over, and okay. So I'm gonna copy paste this part. So we consider the real number line. It mentioned negative 1, it mentioned 2, Okay, so f of x has a negative derivative over net infinity to 1 to negative 1. That means if the derivative is less than 0, we know the function is decreasing, right? Negative derivative shows the function is decreasing over that interval. So it's decreasing here. And from 2 to infinity also decreasing. And a positive derivative over negative 1 to 2, that means it's increasing over negative 1 to 2, right? And f prime negative 1 equals 0. That means we have a critical value. We have a critical point here. That makes a minimum, right? And here is 0 as well. Okay, hold on. Does not. Let me see. F prime of 2. F prime of 2 does not exist. Okay, that's good to know. F prime of 2 does not exist. F prime of 2 does not exist. Might have a like that. And this one is going to be smooth. Let's see which function. Oh, does not exist. Here, does not exist. So it has, the curve is going to have a minimum at negative 1. This one is out. It does not have a minimum at negative 1. This one is out. It does not have a minimum at negative 1. This one seems yes, but since the whole curve is smooth, look like a polynomial function with degree 3, right? Since the whole curve is smooth, that means the whole function is, differentiable everywhere. However, the question tells us the function is not differentiable at 2. So we would have to choose D. Multiple choice questions make a lot of things a lot easier. Please use the method of elimination. We have this right here. We have like a pointing thing, like an angle here. There is no slope, tangent line here. So the function is not differentiable at this point. So we would have to choose D. Okay. Question number 27. So we finished half of it finally, right? It's very lengthy. Let me double check the review. You really should prepare the review as early as possible. Make sure I'm recording and I'm not mute. Okay, let's do the other half. The other half of the review. The graph of the derivative f prime is shown to the right. So this is not the graph of f. Instead, it's the graph of f prime. Use the information in the graph to determine where f is increasing or decreasing and the x values of any extrema. Then sketch a possible graph of f. Okay. Very important. This is f prime, not f. And we can what we can know from this graph. We also need to know this point and this point. That look like, so this is orange. 1, 2, 3, negative 3. That means f prime of negative 3 is 0. Okay, well, I'm using red. So that means f prime of negative 3 is 0. 1, 2. This is 0. Negative 1, negative 2, negative 3. Yeah. And this is positive 1. F prime of 1 also is 0. Since, so from net infinity to negative 3, I'm gonna actually draw a Rule number 9. This is 93, this is 1. From 90 infinity to 93, this part, from 90 infinity to 93, f prime is below the axis, right? So that means f prime is less than 0. F prime less than 0 means the function is decreasing. Function is decreasing here. From 93 to 1, f prime is positive, right? F prime is positive, that means the function is increasing. That actually makes 93 a minimum, right? Minimum. And from 1 to infinity, f prime is less than 0, so that means it's decreasing again. And that makes 1 a maximum. The reason we know it's going to be a smooth curve is because f prime is differentiable. Exists means the function is differentiable in the domain, the whole domain. If a function is differentiable at a point, then the function is also continuous at that point. So that's why we know we're going to have a smooth curve, like something like that. Okay. How do we answer the question? Where is the function increasing or decreasing? Select the correct choice below and if necessary, fill in the answer boxes to complete your choice. Simplify your answer. Type your answer in interval notation. Use a comma to separate answers as needed. The instructions in the parentheses always important. Let's look at the 4 answers, only 3. Okay, let's look at the 3 answer choices. B says the function f is increasing and never decreasing. That's not what we had earlier, right? We had increasing and then decreasing and then increasing and then decreasing. So B is out. C, the function f is decreasing on and never increasing. So B and C not correct. A is correct, but we need to enter the intervals over which the function is decreasing and increasing. The function is decreasing on negative infinity. Use this, okay? Use this. Negative infinity to negative 3. It says use a comma to separate the two domain. Hold on. Okay, I'm gonna do it again, okay? It's we have 2 intervals, so I'm going to write 2 intervals, use a comma to separate it. The first one is negative infinity. That's plus. Negative infinity to negative 3. And another interval is decreasing, right? Decreasing. This was decreasing and this decreasing. Decreasing 1 to infinity. 1 to past infinity. 1 to past infinity. And increasing between negative 3 and 1. So negative 3 left in the point, 1 right in the point. And also I mentioned in the last video, sometimes you are not careful. You finish this, right? And then you accidentally click somewhere else and actually you choose another answer. Try not let that happen. Make sure you want to choose A and A is chosen. And let me double check. Increasing in the middle and the other is decreasing. Decreasing, increasing, and decreasing. Is that everything? No. Okay. What is the x values of the relative minimum or maximum? Select the correct choice below. If necessary, fill in the answer box to complete your choice. The relative minimum occurs at as we have analyzed earlier, occurs at -3. And the relative maximum occurs at 1. Simplify your answer. Use a comma to separate the answers as needed. Continue. Sketch the possible graph. Which one is the same with ours? Is go down first, then go up, and then go down, right? Yes, this one. Question number 28. For the following function, part A, give the coordinates of any critical points and classify each point as a relative maximum, a relative minimum, or neither. B, identify intervals where the function is increasing or decreasing. C, give the coordinates of any points of inflection. D, identify intervals where the function concave up or concave down. E, sketch the graph. This is a lot, okay? First derivative, second derivative, and the graphing. Luckily, the function seems not very challenging. Part A, what are the coordinates of the relative extrema? Select the correct choice below and if necessary, fill in the answer to complete your choice. So let's see. Let's firstly take the derivative of the function. Be patient, this question is going to take a little bit of time. G prime 3x squared minus 24x plus 45. You need to be able to take the derivative very fast because it's just one tiny step in the whole process. If you're struggling even taking the derivative, the whole process is going to be very, very challenging to you. 3x squared minus 24x plus 45. And since later we are going to determine the inflection point of inflection, and concave up, concave down, that means we need the second derivative. So I'm going to do this here, 6x minus 24, all right? Okay, now we let the first derivative to be 0. Then 3x squared minus 24x plus 45 is 0. And as we can see, 3, 24, 45, they are all divisible by 3. So we are going to get rid of the factor 3 here. We have x squared minus 8x plus 15 equals 0. Factor the left side, x minus 3, x minus 5, 93, 95, multiply 15, add up to 98 equals 0. So we have x equals 3 or x equals 5. 3 and 5 make g prime as 0. That means g prime of 3 is 0, g prime of 5 is 0. 3 and 5 are critical points, critical values of the function. And we don't have to worry about a point or a value the function is not differentiable because the function g is a polynomial function. Polynomial function has a domain all-real, and in the domain all-real from net infinity to past infinity, a polynomial function is continuous everywhere and also differentiable everywhere. It is a curve. Of course, the shape is different, depends on the degree, but smooth curves. So we don't have to worry about any point at which the function do not have the first derivative. So it always have, okay? So we only have two relative extrema. Which one is the maximum, which one is the minimum? I'm gonna use the second derivative test to make that decision, okay? Let me see what is a g double prime of 3. Means I'm gonna plug in x equals 3 here. 6 times 3, 18. 18 minus 24, I don't really care the value, I know is negative, right? And that's enough. Since the second derivative is less than 0, less than 0 means a concave down. This is the maximum, okay? On your scratch paper, you're gonna note that's gonna be a function gonna have a relative maximum at 3. And then I also want to know the second derivative value, second derivative of the function at 5. Plug in 5 here. 6 times 5 is 30. 30 minus 24 is bigger than 0. Second derivative bigger than 0, that means concave up, so this is a minimum. What I used just now is the second derivative test. We do have both relative minimum and maximum, so let's read the 4 answer choices. B says there are no relative minimum, so B is out. C says there are no relative maximum, C is out. D says there are no relative minimum and there are no relative maximum. Of course, D is out. We have to choose A. The relative minimum points are and the relative maximum points are. Is or are, depends on how many you have. Simplify your answer. Use integers or fractions for any numbers in the expression. Type an ordered pair. This is very important. We are looking for the minimum, relative minimum point. It's not just a relative minimum value. So we need to, do more work here. We need to know what is g of 3 and g of 5. We need to know what is g of 3 and what is g of 5. G of x is x cubed minus 12x squared plus 45x plus 1. Okay, what do we want to do? We want to know g of 3 equals what? We want to know g of 5 equals what, right? Okay, do you really want to plug it in? Plug x equals 3, of course you will get a value, right? But let's use a better way to find the g of 3. In pre-cal, you might learn this in pre-cal, I believe. Yeah, what is g of 3? I taught this part when I teach pre-cal. So we're going to use a synthetic method. And I decided to use that method because the function g is a polynomial function. And the polynomial function is already in a standard form. So it should be very convenient. Coefficient of x cubed is 1. The method is called the synthetic method, okay? You should remember that. Coefficient of x cubed is 1. Coefficient of x squared is negative 12. Coefficient of x is 45. Constant is 1. And then we're going to put a 3 here. Bring down 1. 1 times 3 is 3. Negative 12 plus 3 is negative 9. 3 times negative 9, negative 27. Be very careful, the calculation. 45 minus 27, 18. Yes, 15 minus 7 is 8. 3 minus 2 is 1. Yeah. And then keep going. 18 times 3. What is 18 times 3? 3. 54. 54 plus 1 is 55. I would want to double check one more time. Bring down 1, 3, it's negative 9, negative 27. It is 18. 18 times 3, 54. 54 plus 55. Okay, the remainder here, that is at g of 3. So g of 3 is 55. Okay. So the relative minimum maximum point is going to be 3, 55 for maximum. On your note, you are going to, on scratch paper, then write that down. And similarly, we can find g of 5. This is going to be faster than you plugging in a function. So 1, negative 12, 45, 1. Put a 5 here. 1 times 5 is 5, negative 12 plus 5, negative 7, negative 35. 5 times 7 is 35, negative. 45 minus 35 is 10. 5 times 10, 50. 50 plus 1, 51. Yeah. So the relative minimum point is 5, 51. Double check. 1. Then 12, 45, 1. Just make sure I did not copy anything wrong. Yeah, only second coefficient is negative. 5, negative 7, negative 35, 10, 50, 51. Okay. Okay, so let's see, where do we enter that? The relative minimum is 551. Look at your scratch paper. Is that 51? Relative minimum is 551. Relative maximum is this, is 355. Oh, this is a long process, right, to figure that out. I hope this is correct. Okay, very good. And that's only part A. Part B. On what intervals G increasing or decreasing? Select the correct choice below. And if necessary, fill in the answer box to complete your choice. Earlier we mentioned we don't have to worry about, we know if you take pre-cal, you should know the basic shape of a polynomial function with degree 3, right? It's always either look like this or look like that, So it's gonna be a smooth curve. It has a minimum at 5, maximum at 3. That means reach maximum first, and then minimum, this is a 3, right? Maximum, this is a 5. After 3 is a minimum. So it's going to be something like that, the curve. So the interval that the function increasing is going to be net infinity to 3 and 5 to past infinity. The interval that the function is over which the function is decreasing is 3 to 5. Okay? The function is increasing on net infinity to 5 to 3. Net infinity to 3. Separate. Do what the instruction says. And 5 to infinity. Which interval is decreasing? Decreasing is in the middle, 3 to 5. Because the maximum is here at 3. So maximum first, minimum after. Has to be like this. So the interval over which the function is decreasing is 3 to 5. 3 to 5. Double check. Net infinity to 3 increasing. And then 3 to 5 decreasing. And then 5 to infinity increasing. Okay. Part C. What are the coordinates of the inflection point? The point of inflection. Select the correct choice below. Okay. We do have the second derivative found, right? Let me rewrite that here. G double prime x equals 6x minus 24. 6x minus 24. we make the double prime equals 0, then that means 6x minus 24 equals 0, plus 24 plus 24, that means 6x equals 24, divided by 6, x has to be 4. Only when x equals 4, double prime is 0, right? So it does have an inflection point. Also, you see the polynomial function with degree 3 do have only one inflection point. Okay, so the inflection point happens at a 4. Not B, it's A. Use a okay, so here, type and word pair is very important to know that, because you are not going to just enter 4. 4 is just the x coordinate of the point, inflection point. We also have to figure out the y coordinate. How do we find the y coordinate? The y coordinate is going to be g of 4, right? G of x is the original polynomial is x cubed minus 12x squared plus 45x plus 1. Double check, x cubed minus 12x squared plus 45x plus 1. To find the g of 4, unless you really enjoy just plugging in, we're going to use the synthetic method again. 1, negative 12, 45, 1. Put a 4 here. Bring down 1. 1 times 4. This is negative 8. Negative 12 plus 4, negative 8. 4 times negative 8, negative 32. 45 minus 32, 13. 5 minus 2 is 3. 4 minus 3 is 1. 4 times 13 is 52. Right? Yeah. 52 plus 1, 53. 53 is g of 4. So the inflection point, 53. So the interval concave up, concave down, we can tell from the graph here, the inflection point is right here. So from the left side, on the left side of 4, okay, is a concave down. On the left is concave down first and then concave up after. So the function is concave up. 4 to infinity. Concave up to the right, on the right side, to the right of 4. Concave down to the left of 4. Negative infinity. So that's the equal sign. Negative infinity to 4. Some students might wonder, what if I have a TID for calculator and I just use the calculator to graph the function and then to answer the question? Would that be okay? That is okay. Later I'm gonna look at how many minutes I spent on that question. So let's continue. This is question number 28. Oh, still the same question. We're not done yet. Part E, choose the correct graph. Which one? This one, D, right? Oops, I'm sorry. Oh, A and D do look similar, but the maximum is 3, inflection point is 4, minimum is 5. This one, 1, 2, 3, 4, also 5. So we need to look at A and D. And what's the difference between the two functions? The inflection point is 4, 53. 4, 53. Let's see. 4, 53. This look like this is 50. This is 60. So 1, 2, 3. This is 55. 53. Seems like 53. And this one, this is a 48. And that is 62. 50. It's 48. 50, 2, 4, 6, 8, 10, 2. So this is 50. And this y value is off. I would choose, should we choose A here? Wow, it's very challenging problem, right? Question number 29. Sketch the graph that possesses the characteristics below. F is concave up at 1 to 4, concave down at 7 to 7, this is not interval, this is a point. At 7.96, comma 96, and it has an inflection point at 3.91. Let's see. At 91.4, 91.4, function concave up from 7.6, concave down, inflection point 3.91. This is so small. It does not look like -1. What about this one? Inflection point 3.91. 3.91. 1, 2, 3.91. That one seems right. 91.4. 91.4. No, it's not even passing that point. This one, inflection point 3.91. 1, 2, 3, 91. 91.4, concave up. 796, concave down. I would, consider C, but let's look at the D as well. The inflection point is above. Oh, try C. Okay. That's it. Okay, next question. Question number 30. We are given a graph. The corresponding function is shown on an interval 95 to 5. Okay. Determine whether each is less than, greater than, or equal to 0. Oh, okay, got it. So this is the function f. Since, as you can see, the curve from 95 to 5 fall above the x-axis, that means the function f, the whole function is bigger than 0 in the domain. You see the domain is 95 to 5. Since the function is increasing over this interval, increasing means that first derivative is positive. We're going to choose that. First derivative positive, so it's increasing. And also we can see the curve is a concave up. Concave up means second derivative is positive. you also need to know what if the curve looks different, right? If it's concave down, which one do you choose? Question number 31. Didn't we do a similar problem earlier? This is different, right? Okay, so sketch the graph that possess the characteristics below. This is different. It has f prime of 1 is 0, double prime of 1 is less than 0. That means the function has a maximum at 1. Okay, let's see which function has a maximum at 1. This is way more than 1, right? These is out. I didn't mean to choose this, by the way. Maximum at 1. Okay, this one, we're going to keep this one. Maximum at 1. This doesn't work. Maximum at 1. Okay, we can keep this one for now. Either B or D. At 5, slope is 0, concave up as well. At 5, concave up, that means 5 is minimum. So has a minimum at 5. Has a minimum 5. Okay, this question. This is I need to make it bigger, this one. 1, 2, 3, 4, 5. Another maximum, but no. Has to be minimum at 5. I assume the marking 1, 2, 3, 4, 5. Huh? 1, 2, 3, 4, 5. Okay. I'll choose D. Use method of elimination. You don't have to use all the information. You can use just get rid of the 3 wrong answer. You wouldn't know which answer is the correct one. Question number 32. Determine the vertical asymptotes of the function if none exists. State that fact. All right. So the denominator is easy to factor, right? Do you remember the definition for rational function? Rational function is a quotient of 2 polynomials. Means the numerator is polynomial, denominator is polynomial. So we use factorization of polynomial a lot. Numerator is not factorable, but denominator can factor as x minus 6 and x plus 6 and x minus 6. Take the opposite, so x equals -6, x equals positive 6. Those are the 2 vertical asymptotes. Because when x approaches to -6, the y value approaches to infinity. Same with this one. 2 vertical asymptotes. 3, 2, 1, none. So second. The leftmost asymptote is x equals -6. If you only enter -6, that you got it wrong, because you have to type an equation as the problem shows. You have to type an equation. The equation for that vertical straight line is x equals -6. The rightmost asymptote, vertical asymptote, is x equals positive 6. Question number 33. Determine the horizontal asymptote. Okay. How do we do this one? To find the horizontal asymptote, we look at the degree of the numerator and the denominator. For this question, numerator degree 1, denominator degree 1. When the numerator and denominator have the same degree, the horizontal asymptote is y equals the quotient of the 2 leading coefficients, 6/14. 6/14. We only have one asymptote, okay? We only have one horizontal asymptote, so choose B. The one horizontal asymptote is y equals 6/14. is correct but not simplified. 6 over 14 is 3 over 7. 3 over 7. It doesn't mention decimal or anything, right? It doesn't, okay, just a fraction. Question number 34 is to find the horizontal asymptote. As I mentioned, to find the horizontal asymptote of a rational function, we look at the degree of the numerator and the degree of the numerator. In this problem, degree of the denominator is 2, degree of the numerator is 1, so the degree of the denominator is bigger. In this case, the horizontal asymptote is y equals 0. 1 asymptote, oh, 2, sorry, 1 is here. Y equals 2, y equals 0, okay? Y equals 0. Just imagine the bottom, when x approaches infinity, top approaches infinity, bottom also run to infinity. But the bottom has a higher degree, so it runs faster. Right? Because the bottom runs so fast, that seems like the numerator doesn't change. So when the numerator does not change, the denominator goes to infinity, the quotient goes to 0. So y equals 0. Feel free to email me if you have any questions, because I feel like I'm going over those questions quite fast, because this is a review. I assume you have already learned the content from the note and the textbook. Question number 35. Find the absolute maximum and minimum values of the function over the indicated interval and indicate x values at which they occur. Absolute, okay, absolute. Let's see, how do we do that? First thing I notice, this function is an odd function. It is an odd function. Odd function has a curve symmetric with respect to the origin. And yeah, this is odd function because the domain also symmetric with respect to the origin. Okay, let's use the regular process to find the absolute extrema. Take the derivative. I'm gonna change this to y, and f as the numerator, g as the denominator. I'm gonna use quotient rule to take the derivative, okay? F is 5x, g is x squared plus 25. F prime is 5, g prime is 2x plus 0. And f over g prime is f prime g minus f g prime all over g squared. F prime is 5 times g, f prime times g, minus f times g prime. Denominator g squared x squared plus 25 to the power 2. Simplify the numerator. Let's distribute. 5x squared, 25 times 5, 125, minus 10x squared, 5 times 2 is 10, negative 10x squared. Denominator x squared plus 25 to the power 2. Continue simplifying the numerator. 125 minus 5x squared. 5 minus 10, negative 5, x squared. And this is x squared plus 25 to the power 2. There's nothing we can simplify. This is the first derivative of the function. Okay, we are looking for the absolute extrema, right? So we make y prime equals 0. That means we need this be 0. Knowing this notation means make it be 0. It's my own notation. You don't have to use it, but I will explain when I use it. Make this expression be 0 because this expression is the first derivative of the function. Make it be 0. The denominator cannot be 0, as you can see. It's always a positive because here's plus, right? x squared is positive. At 25 is also positive. Square is also positive, so not equal 0. So in order for the quotient to be 0, the numerator has to be 0. Okay, solve this equation. We have 5x squared equals 125 divided by 5. We have x squared equals 25. I skipped a little bit, steps. You move this term to the right, you have positive 5x squared equals 125. So x squared is 25. X plus 1 minus 5. Okay, so we do have two critical values, -5 and +5. And we also have boundaries, right? So we're gonna consider -7, -5, +5, and +7. We want to know. Now we're gonna go back. This is f. We want to know what is f of -7, f of -5, f of 5, and f of 7. We cannot do synthetic because this is not polynomial. So we would have to plug in. Good news is we know it's an odd function. You can use the property of odd function. You don't have to do. You can reduce the calculation amount. If we plug in 5 in the function, the numerator is 5 times 5 is 25, and 5 squared is 25 plus 25, that is half, right? Bottom is 50, so half. Since it is an odd function, f of -5 is going to be -half. All right, I hope you still remember odd function, even function from pre-cal. If you don't remember, it's still okay. You just need to plug in -5. You would have the same result. And now I'm going to plug in 7. If I plug in 7, plug x equals 7 into the function, numerator is going to be 35. Denominator 7 squared is 49 plus 25. 35 over. What is 49 plus 25? 74. I think it's already simplified, but I'm going to double check here. Calculator, TI-84 calculator had this very interesting, useful 49. 7 squared is 49 plus 25. 49 plus 25. And I can use math fraction. Help me to calculate and simplify. 35 over 7. Yeah, it is already simplified. You want to know the decimal? 35 divided by 74. As a decimal, it is less than half, right? So yeah, it's less than half. And this f of 97 also use the property for odd function is going to be -35 over 74. And as we can see, since the function is continuous in this on this closed interval, it's gonna have both maximum, absolute maximum, and absolute minimum. As we can see, half is bigger than 35 over 74. So this is going to be the absolute maximum. This is going to be the absolute minimum. Okay. All right. So absolute maximum happen at 5, occurs at 5. Absolute minimum occur at -5. Let's go back. The absolute maximum occur is half. Remember that? 1 over 2 occur at x equals 5 positive. Oops. The absolute maximum value is half. rounded to 2 decimal. Okay, as needed, use a comma to set. Does that mean I have to use 0.5 here? 0.5. Yes, so be very careful, guys. Be very careful. Even I think a half is nothing wrong. It's nothing wrong. Half is 0.5. But the question requires to enter decimal. We would have to do that. The absolute minimum is negative half, negative 0.5. Well, I learned my lesson. And it happens at negative 5. Alright, so be very careful. In the exam, you only have one attempt. If you mess up just one tiny bit, you waste the whole energy to analyze the function, the question. Problem number 36. Find the maximum profit and the number of units that must be produced and sold in order to yield the maximum profit. Assume the revenue and the cost functions are in dollars. So we have the revenue function and the cost function given. What is the production level for the maximum profit? Okay. Profit function, P, is revenue function minus cost function. Revenue function 2x, cost function is this trinomial 0.02x squared plus 0.6x plus 6. Let's remove the parentheses. 2x minus 0.02x squared minus 0.6x minus 6. Combine like terms. Negative 0.02x squared. 2x minus 0.6x is 1.4x minus 6. So the profit function is a parabola. I hope you see that. Since the leading coefficient negative is going to be a parabola opens downwards, right? And it does have a maximum. So the maximum is going to occur at the interval vertex. Do you guys still remember h comma k? Oh, we actually don't have to do that, right? Since we have already learned the derivative. So let's take a derivative. Let's take the derivative of the profit function. Negative 0.04x plus 1.4. Make the derivative of the profit function as 0. I mentioned that this means make it be 0, right? It's my own notation. Then we have 1.4 negative 0.04x plus 1.4 equals 0. And then negative 0.04x equals negative 1.4. And positive, and then divided by 0.04 here, 0.04 here. X equals 1.4 over 0.04. 35. That means the maximum profit is reached as x equals 35. 35. What's the production level for the maximum profit? And just make sure it doesn't have like a million or 1,000. It's just 35, okay. What is the profit? When you produce 35 units, the profit is going to go back the function. You would have to plug in this here. Plug 35 there. So that's when you have a TID for calculator, that's going to be make it a little bit easier. I'm going to use that. Remember, negative sign is this one, okay? 0.02 negative 0.02 x squared, so 35 squared plus 1.4x plus 1.4x, x is 35 plus 1.4x, and minus 6, 18.5, $18.5. Let's go to the question. In dollars. Yeah, it is in dollars. 18.5. This must be a very tiny business. Okay, next question. 37. Find the derivative of implicit differentiation. Okay, find dy dx. I hope you have learned the basic about implicit differentiation. We are looking for dy dx, right? So knowing y is a function of x, y depends on x. So when we take the derivative, so what are we going to do is we're going to take the derivative of each single term in the equation. But when we have a y, we need to have a dy dx by the end. When we only have x, we don't have to worry about that. So on the left side, keep 4. Derivative of y squared is 2y. But remember, y is a function of x, so remember to multiply by dy dx. Is based on the chain rule. So basically, if this term only, if you only have a y, you always have to follow with the dy dx here. And second term only have x, then you don't have to worry about that. The derivative of x squared is 2x, so 14x. The derivative of 7 is 0, it's constant. So now we are going to solve this equation for dy dx. Okay? Simplify. 4 times 2 is 8y. 8y times dy dx plus 14x equals 0. Minus 14x minus 14x cancel. 8y dy dx equals negative 14x. Divided ay divided 8y, cancel 8y dy dx equals negative 14, 8, they both have factor 2, 7x over 4y. That is the dy dx. Negative 7x over 4y. Oh, it's a multiple choice question. Negative 7x over 4y. This one, D. Question number 38. Differentiate implicitly to find the slope of the curve at the given point. Same with earlier, but we would have to plug in x equals 2, y equals 1 after we have dy dx. Okay, so the answer, of course, after we plug in, we can have a constant. Same with earlier, but this time on the left side, we have a product. Do you guys remember product rule? F prime g plus fg prime, right? Okay. So on the left side, we take the derivative of this, we get a 5x to the power 4th, right? Take the derivative of the first function, multiply by the second function, which is y to the power 5, unchanged, right? Plus, keep the first function unchanged, and then multiply by the derivative of the second function, is 5y to the power 4, and dy dx. Remember, we always have to have dy dx after you take the derivative of 1. Let me double check. Yes, right side is 0 because the derivative of a constant is 0. Okay. Then we're going to move this term to the right. We're going to have 5x fifth y fourth times dy dx equals negative 5x fourth y fifth divided each side by 5x fifth y fourth, 5x fifth y fourth. This cancel, and dy dx equals 5 cancel 5 is negative y over x. And now we're plugging in x equals 2, y equals 1 is given, okay? We're plugging in x equals 2, y equals 1, x equals 2, y equals 1, y is 1, x is 2, so negative half, 8. Question number 39. Change of rate. Related rate. Related rate. This video is very long. I'm getting tired. Related rate. So in this related rate problem, x depends on t, y also depends on t. T is the input variable. We're going to treat x as a function depends on t, y also the function depends on t. The implicit function is y equals root x. On the left, we are going to take the derivative of y first, and then dy dt. On the right, we are going to take the derivative of x first, and then follow with dx dt. Do you remember this formula I make you to memorize? We are using it now, right? So the derivative of root x is 1 over 2 root x, and times dy dt, dx dt. And let's see what we have. We have dy dt is 1. dy dt is 1, so 1 times 1 is 1. On the right side, root x is y. Root x is y, and y is 9. So 2 times 9, because root x is y, y is 9, right? Times dx dt. Dx dt is what we need to find. 1 over 2 times 9 is 18, dx dt. So multiply each side by 18. We have dx dt equals 18. Related rate. Let's see. Dx dt. We change dx dt. Oh, it's not 1. I cut it wrong. 1.95. Oh, I'm sorry. I read it wrong. 1.95. So dy dt is 1.95. I'm sorry. 1.95. 1.95. 1.95 times 18. 35.1. 35.1. So be very careful. You don't need 100% to get A, right? You only need 90% to get A. And this one, okay, from this problem, I believe the next 12 questions, 13 questions going to be integral. Okay, so this is an indefinite integral. I'm going to process in a note. Okay. So we're gonna find the antiderivative, right? So do you remember the quotient rule? So the antiderivative of x to the power n is n plus 1 on the bottom and x to the power n plus 1. I hope you remember this formula and plus c. So the antiderivative of this function, power function, has a higher degree. Degree is one more than the original function and over the same degree. So with that said, firstly, for convenience, we want to write both of the two functions in the integral as a power function. So we're going to write 7 over x as, or 7 over x, okay. 1 over x, so you know this function, right? 1 over x dx. The antiderivative is ln x absolute value of x. So this part, I'm going to do this first. 7 over x dx minus 15 over x to the fifth 6 dx. And 7, 1 over x, that is ln absolute value of x. And then minus 15, the coefficient keep the same. And 1 over x to the power 6 is x to the power negative 6. Use the formula here. Negative 6 plus 1, negative 5. And then x to the power negative 5. And then plus c. So 7 ln absolute value of x. Negative is positive 3 over x to the fifth plus c. So that is the answer. If you are not sure, you can always go back, right? I think for most of the students, taking the derivative is more familiar than taking the integral. So you can, once you have your proposed solution, you can take the derivative of the function to see if you go back the original function. I think it looks, yeah, I think it's correct. This definitely is correct. So 7 ln absolute, use parentheses to clearly denote the argument of each function. Okay. Use parentheses to clearly denote the argument of each function. The argument of each function. So I would have 7 ln absolute value of x plus 3 over x to the power fifth plus c. Use parentheses to clearly denote the argument of each function. Do I need a parenthesis here? But I think absolute value is a grouping symbol already. Okay, that's fine. I don't really understand what does this mean though. Next, number 41. Find the integral. Okay, this one is, I'm gonna just write it here, okay, because it's pretty simple. It's going to be 9x squared over 2. You're looking for antiderivative, right? And oh, my bad. There's a square here. My bad. And the hint is expand first. I apologize because I'm getting tired. Then follow the hint. Follow the hint. Let's expand the function first. You can FOIL or use the perfect square trinomial formula. 9x plus 5 to the power 2 is 81x squared plus 90x plus 25. Let me double check. Yeah. So the integral of the function would be integral of 81x squared plus 90x plus 25 dx. And then we're going to do the antiderivative, 81. Here we have 3x cubed. And here 90 of x squared over 2. And plus 25x plus c. Do not forget, always have a c. 81 divided by 3 is 27x cubed plus 45x squared plus 25 plus c. Okay, you can go back, take the derivative to see if you have this one, right? It's actually, yeah, it does. So 27x cubed, 27x cubed (45x squared) plus 25 plus c. I always use capital C. I don't know if you use a lowercase c will get messed up, but use capital C. 27. Okay. Do I miss a x here? So be very careful. 25. You see, did I mess it up? A detail here. But I realized that and I fixed it. 25x. 25x. Okay, looks good. Question number 42. A company finds that the rate at which the quantity of a product that consumers demand changes with respect to prices given by this marginal demand function. Okay, demand function and it has the marginal demand function, so the derivative of the demand function, where x is the price per unit in dollars. Find the demand function if it is known that 1,003 units of the product are demanded by consumers when the price is $2 per unit. Okay, so we are given D prime, we are looking for D. That's what we have for this question. Okay, d of x equals integral d prime x dx, right? So d prime is negative 2,000 x squared dx. And if we take 2,000 out, the function in the integral would be negative 1 over x squared dx. Do you remember multiple times I have mentioned this formula, right? And you should know the antiderivative of negative 1 over x squared should be 1 over x. So 2,000 times 1 over x plus c. Do not forget to plus c. So 2,000 over x plus c. We won't have the demand function unless we know the value of c. How do we know the value of c? We have a piece of information. It says, so this is the demand function we got, right? But we don't know the value of c. It says when the price is $2 per unit, the demand is 1,003. So 1,003 is the demand when the price is $2. We're plugging in the demand function. Then the demand function should give us an identity. And this equation is a true statement. C is the only unknown. We can find the value for C. So 1003, 2000 divided by 2 is 1000 plus C. C has to be 3. So the demand function is 2000 over x plus 3. 2000 over x plus 3. Question 43. Find the integral. Okay. So this is a multiple choice question, right? And you really could just go back, check each answer choices. There's this formula. If you remember this formula, of course, it would help. If you remember this formula, and our k, plus c, sorry. Our k here is negative 0.2. So you're gonna have a negative 0.2 on the bottom. 7 divided by negative 0.2 is going to have a negative 35. It's this one. It's this one. 7. Question number 44. Explain what the shaded area represents. It represents, this is a velocity, and this is a time in hours. It represents the total number of velocities. Total number of it takes to travel one. The total number of miles traveled in T hours. The average number of miles traveled in T hours. The total number of hours it takes to travel. Average miles per hour. Okay. This is velocity, miles per hour. It's velocity function. Okay. Velocity function Vx dx from 0 to t. T here you can treat it as a constant. So we know position function prime is velocity function. That means the antiderivative of v of t is s of t. So it's going to be s of t minus s of 0. So this actually gives us how many distance, how many miles it traveled. How many miles traveled in total? Total number of miles traveled in T hours. Question number 45. Find the position function. Okay. If the velocity function is given, remember earlier we say position function is the antiderivative of the velocity function. So s of t would be the integral of v of t, right? Plus c. Plus c is later. Okay, so we're gonna have v of t is 12t squared dt, and it keep 12 and t cubed over 3 plus c is 4t cubed plus c. And then since s of 0 equals 1, when t is 0, s is 1, right? So we right now we have s equals 4t cubed plus c. We want to know the value of c. Plugging in x equals 1, t equals 0, so t is 0, so just 0. So c is 1. So the position function would be 4t cubed plus 1, right? 4t cubed plus 1. I would recommend you always, once you have your proposed solution, always check by taking the derivative of the result to see if it go back, give you the original function. Like now you have a position function. We know the derivative of position function is a velocity function, right? And you take the derivative of this function, you have 12t squared. And also plugging in when t equals 0, s is 1. So it's correct. Question 46. Find the area and the graph of the function over the interval given. We are looking for a definite integral from 1 to 4, 1 over root x dx. Okay, guys, again, how many times this I mentioned in the 2 videos? The derivative of root x is 1 over 2 root x, all right? And this is so close. So if I multiply by 2 on the bottom, multiply 2 in the numerator, and I have 2, bring 2 in front, 1 to 4, 1 over 2 root x dx. And keep 2 outside, okay? Take the bracket. And the antiderivative of this function is root x. So it's going to be the antiderivative of the function is root x, and it's going to be the root x at value 4 minus root x at value 1. This is my notation. I don't know if you can do this. And then take the bracket. And in the bracket, you must have 2 parentheses, 1 parenthesis minus the second parenthesis. In the first parenthesis, you're going to plug in 4 here, so root 4. In the second parenthesis, you're going to plug in 1, root 1. Root 4 is 2, root 1 is 1. So 2 minus 1 is 1, so it's just 2. It is just 2. 2 root 4 minus root 1. 2 minus 1 is 1. The area is just 2. Here, D. All right, let me see. Am I still recording? Yes, I'm still recording. I'm not muted. Looks fine. Let's go back. Question number 47. Evaluate the definite integral and interpret the result. Okay, so it's a multiple choice question, so we can take advantage of the method of elimination. The integral from 0 to 3, as you can see, some part fall above the x-axis, some part fall below. Then the integral, the definite integral, actually is the area of the region above the integral, above the x-axis, minus the area of the region below, fall below the x-axis. So which one is out? The shaded region above minus the shaded region below. So keep D for now. The total shaded area is equal to, no, this one is wrong. Shaded area above minus shaded area below. This one, total area is, A and C are out, okay? Either B or D. The difference is the value of the integral. Okay, it won't take too much time to evaluate the definite integral, right? But we can also look at the area. we can estimate the area is not going to be 10.25. It's going to be a smaller number than that. Of course, I would spend a little time to show you it is a smaller number than 10. Let's evaluate this definite integral. Find the anti first. The anti is x fourth over 4 minus 8x squared over 2. Hold on, sorry. It's going to be 2x squared. 2x squared. Minus 2x. Okay. So once you found the antiderivative of the original function, you put it in the bracket. And you put the upper limit here, lower limit here, right? And then you do a parenthesis minus parenthesis. Inside the first parenthesis, you plug in 3. 3. Second parenthesis, you plug in 0. We like 0 because it's just 0. So now we have 81 over 4 minus 18. 81 minus 4, 81 divided by 4 minus 18 is 2.25, right? And also you can count the area and use the area of this minus the area of this. It's going to be small. Okay. Question number 48. Evaluate this definite integral. It's multiple choice question. We have value. The function seems complicated, like a rational function. Good news is the denominator only has one term, so we are going to split. We're going to rewrite the function as t to the a over t to the 6 minus t to the 4th over t to the power 6. T to the power a minus 6 is second power. And this is t 4 minus 6 is negative 2 power. Okay. And this is 1 to 2 t squared minus t to the power negative 2 dx. And we can also write this as 1 over t squared. T squared minus 1 over t squared. Okay, so now we are going to find the antiderivative of the function in the integral. The first part, this part, the anti is t cubed over 3, and this part is 1 over t. Why? Because, again, I mentioned this multiple times, right? So the antiderivative of this part is 1 over t. So now we have the antiderivative, put it in the bracket, upper limit, lower limit, and then we are going to have parentheses minus parentheses. First parentheses, plug in 2, a over 3 plus 1/2. Second parentheses, plug in 1, 1 over 3 plus 1. And then we calculate. So a over 3 plus 1/2 minus 1 over 3 minus 1. A over 3 minus 1 over 3, 7 over 3 plus 1 over 2 minus 1. 2, 2, 3, 3, make them have the same denominator. 14 over 6, 3 over 6, minus 6 over 6. So we have 11 over 6. C. Question number 49. Definite integral as well. Okay. Find the anti. The anti is itself. You know how special the natural exponential function. So put the anti in the bracket. B go here, 0 go here. Parentheses minus parentheses. In the first parentheses, plug in B. In the second parenthesis, plug in 0. Okay, 2e to the power b. E to the power 0 is 1 minus 2. So this is the answer with b in it. 2eb minus 2. 2e to the power b minus 2. This one, D. Question number 50. A company determines that its weekly online sales as of T in hundreds of dollars, T weeks after online sales began, can be estimated by the equation below. Find the average weekly sales for weeks 2 through 5. And actually this tells you T equals 1 to T equals 5, right? Average weekly sale. Average weekly sale. So this is about average is this the formula A to B f of x dx over b minus a. This formula. This is sales. The average weekly, so S of T here is weekly sale. It's already just a sale. The nearest cent as needed. Okay, T from 1 to 5. We can find by using this formula. 1 to 5. So this is 1 to 5 S of T dt over 5 minus 1. 5 minus 1 is 4, so we have 1 over 4 here. 1 to 5, 5 e to the power t dt. We can bring 5 out, so 5 over 4 outside. 1 to 5 et dt. And the anti is the same function, e to the power t. So we're going to have e to the power 5 minus e to the power 1. Let me double check quickly. 5 over 4. Yeah, 5 over 4. Times parentheses e to the power of 5 minus e to the power of 1. In hundreds of dollars. How many dollars? So we're going to multiply by 100 here. Multiply by 100. And then round it to the nearest cent. 86. Okay, see right here. 86. $51. Find the area of the shaded region. This shaded region is between two curves, right? Oh, of course, this one is a straight line, but we can see that as a graph between two graphs. And we need to know is from -1 to 4. Okay, this is important. and the straight line on the top. So we're going to use G to minus F and go from -1 to +4. G is a straight line. F is a polynomial function, a curve. So it's G minus F from -1 to 4. Okay, so I'm gonna find the G minus F first. G is 10x plus 40. F is x to the power 4th minus 8x cubed plus 21x squared. (10x plus 40 minus x to the power 4th plus 8x cubed minus 21x squared. Negative x to the power 4th plus 8x cubed minus 21x squared plus 10x plus 40. Let me double check. Okay. And from -1 to 4. Find the antiderivative of the function. Put it in the bracket. It's going to be x to the power 5th over 5. And this one, 2x fourths. This one, 7x cubed. This one, 5x squared. This one, 40x. 491. So parentheses minus parentheses. In the first parenthesis, plug in 4. In the second parenthesis, plug in -1. This is going to be a very complicated number. Don't think we have a shortcut for this problem. We would have to do this. Okay, so I can use the calculator to help me. This is -4 to the power 5th. Uh, 4 to the power 4th. Minus 7 times 64 plus 5 times 16. This one is 160. This is 9 plus 5, 14. Minus 40. Okay. Minus 1, 0, 2, 4, 5. 512. 512. Yeah. And minus 64 times 7. 448. And plus 16 times 5 is 80. It's 160. And minus 1/5 minus 26. I don't really wanna, so let's do this. 512 minus 443. This make 240. It's 26. $330. $330 minus 1025 over 5. That is 205. $125. The calculation is quite challenging, but I don't really see a better option. 125. Okay. Next is the last question. Okay. Number 52. Find the area of the region enclosed by f and x-axis for the given function over the specified interval. It's piecewise. And then y is between, is right inside, right in the interval. So we're gonna have to, the area is 95 to 2 f of x dx, right? Because this is a positive, and it's also positive, so yeah, we can do that. The important thing is we know this function is positive. This is also positive over the corresponding interval. So we can use this integral definite integral to represent the area, because it's gonna be all about, the curve is gonna all about the x-axis, no area below, so that's important. So since it's a piecewise function, we're gonna have to write this integral as 95 to 1, 1 to 2. Okay, from 95 to 1, function f is the first piece, x squared plus 2x plus 2 dx. From 1 to 2, fx is 3x plus 2. All right, we do one at a time, okay? How about let me use I as this one, 2 as the second integral. And let's do the first one. The anti-derivative x cubed over 3 plus x squared plus 2x, and put in the bracket 195. So parenthesis minus another parenthesis. First parenthesis, plug in 1. Second parenthesis, plug in 95. Double check the entry. Okay. And this one is 1 over 3 plus 3. And this is negative 1 to 5 over 3 plus 15. Calculation has some, strategy. Do not do that. I mean, sometimes you don't have to be careful with find the correct order to do that. Plus 15. So now I'm going to remove the parentheses. 1 over 3 plus 3 plus 125 over 3 minus 15. This one and this one, 126 over 3. This one is minus 12. 126 divided by 3 is 42. Yeah, 42. Minus 12 is 30. So the first definite integral is 30. Now let's do the second one. Second one, you have some space. I can do it here probably. It's this one. The antiderivative, I'm gonna do here. Antiderivative is 3x squared over 2 plus 2x. Double check. 3x plus 2. Okay. 1 to 2. First parentheses, plug in 2. Second parentheses, plug in 1. This 6 plus 4. This is 1/2 or 3/2 plus 2. Remove the parentheses. This is 10 minus 3/2 minus 2. 10 minus 2 is 8. 8 minus 3/2. 16 over 2 minus 3 over 2. 13 over 2. It's not an integer, it's a fraction. And 13 over 2. 60 over 2 plus 13 over 2. 73 over 2. I hope I do not calculate anything wrong. Okay, good. So that's everything. It's a very long video. I hope you enjoy the process. I would recommend you prepare for the review of the final as early as possible, and do not just watch the video or practice the review one time. How about try 5 times first, and another 5 times, until you feel very comfortable with those problems. Alright guys, thank you for watching the video. Please feel free to email me if you have any questions.